Going to explain motional EMF, motional EMF, motional induced EMF, motional induced EMF, induced EMF, motional induced EMF. I will explain the mechanism of this motional induced EMF. For example, like this uniform magnetic field B, say uniform magnetic field like this. If I am given velocity, this is the conducting rod. So conducting rod, length of the rod is L. I am given velocity of this rod along horizontal direction with V, which is perpendicular to the length of the rod. Magnetic field I am consider here what V equal to V naught in minus K cap. Velocity of the rod is horizontal direction. Rod is moving horizontal with the velocity of V, and length of the rod is L, and this is what conducting rod or wire. This rod is moving with the velocity V. This conducting rod having electron and proton. If this rod is moving horizontal, then electron, suppose this is proton able to get force in vertical direction, that is what? Magnetic force. That is value is what? EB cross BB. Okay, magnetic force is nothing but magnetic force is QB cross B. B is what? I cap direction. Then QB cross B is magnitude wise, we can write what? QBB sin theta. Here Q is what? Electron charge of proton, that is what? EBB sin 90. Then magnetic force able to feel by proton is nothing but EBB. This force will act vertical direction, that is a J cap. Look at this. B cross B, V is what? I cross minus K. That become what? Plus J. That's why magnetic force FM cap means direction of magnetic force is what? Plus J cap. Then what happened? Proton, because of the force, magnetic force, proton drag this force try to drag the proton vertical end of the rod, and the negative electron able to get the force downward direction. Then for example, electron is like proton is this and moving with the velocity V. Magnetic field is inside the board, then able to get the force what? Vertical FM force, that is what? EVB. Then electron having negative charge moving with the speed of V like this. Magnetic field inside like this, then electron able to get the force what? Downward direction, that is value is what? Equal to the force on the proton but downward direction. That's why the charges accumulate here. This negative charge accumulated here, negative charge accumulated here, and positive charge accumulate here. Then what happen after a steady state? After a steady state, after a steady state, and that will take very less time. Okay, na? Steady state means what happened? For example, this rod is moving with the velocity v like this. Length of the rod is perpendicular to the velocity, and magnetic field what inside the board is magnetic field v equal to given already v given v naught minus k cap. V given v naught minus k cap. This is inside the board. Inside the board. Now, after when steady state condition, steady state means what happen when the proton accumulate at this end, electron accumulate at this end, then due to the potential drop, electric field will develop downward direction. This is the electric field. Electric field will develop in the rod. Then what happen? Then due to the electric field, the charges, for example, this proton having positive charge plus E, this is able to get magnetic force vertical direction, and similarly due to the electric field direction is downward, then able to get force what? Electric force Fe, that is nothing but what? E into E, downward direction. And magnetic force value is what? Magnetic force value is EBB, or vector form we can write like this. In vector form if you want, then you can write EV cross B. EV cross B. If I am going to generalize this, means I am writing what? V cross B, because in this case able to get V cross B is nothing but VB, but in general case magnetic force is what? QB cross B. And now under a steady state condition means this steady state condition will achieve means net force on the charge become 0. Then able to get what? Magnetic force for steady state condition means magnetic force is equal to electric force. This will balance. Then now I'm equate this equation. Fm is equal to Fe. Then we can write here what? E V cross B equal to E and electric field. Then we can cancel out. Then electric field able to get V cross B. This is a general case. For this particular case, when V and V perpendicular to the V, then electric field become what? VB only for this case. Other case able to get this one. This is the general case. Now, we already know what in electrostatic we know about electric field E dot dl is equal to what? Potential drop. E dot dl is equal to, suppose I am given this point A, this point B, I am given the name is this. In the direction of electric field, potential will drop. That's why this equation is what? E dot dl minus BB minus BA. Then potential, now we can write again, then E dot dl is equal to BA minus BB, means higher potential minus lower potential. Now dl is what here? L only. Then we can write what? E dot L vector is equal to VA minus BB. Then we can write from equation 1, this is the one equation and this is the second equation. From equation first and equation second, now I am going to write what? Electric field potential difference BA minus BB is equal to E dot L vector. Now again we can replace E with V cross B, V cross B dot L. This is the formula when B and B are constants or constant. It's not changing with the time. Now, then for particular rod, for this case, for in this rod is what? Length is what? L, and this velocity given what? Perpendicular V, and magnetic field given what? V equal to V naught minus K cap. Then for this particular case, magnetic field velocity perpendicular, for this case B and L are mutually perpendicular. Yeah, V and R are perpendicular to each other, Then this case able to get what? A minus BB is equal to BBL. And direction of which one in having higher potential and lower potential will easily able to find out with the help of magnetic force, because look at this. When the rod is moving with the velocity V, then magnetic force able to get this direction, and magnetic force try to drag the positive force here and negative force here. Then positive force means direction of magnetic force able to get means that is the direction of moment of the force of positive charge. That's why this end is become positive, this end become negative. Means this having higher potential, and this is what? Lower potential. Then very easily identify what? Which having higher potential, which one having lower potential. Then BA minus BB, that able to get what? BBL. For identify the direction of the which one end of the rod is positive or negative, just able to know what direction of the magnetic force. Direction of magnetic force will decide this. And next case what? When this formula, please remember this formula, this very very important formula. This is very important. Okay, in vector form. In general case we can write this only. For this case is this only. For this particular case is this. Now next. Now the next case, when next case what? For example, in general case means in general case means rod is like this. For example, rod is inclined like this. Magnetic field I am given direction like this. Magnetic field direction is this. This is the rod. Length is L. Magnetic field direction is this. And that rod is inclined at angle theta and moving in different direction. Moving in different direction like this. In that direction. This moving at angle like this. Which angle? V. This is the what? Alpha angle. Then for this case, we can use the formula is what? This electric field formula become what here? V cross V. And VA minus BB, look at this. If I am given this end A, this end B, then potential we can use here V cross B dot L. V cross V dot L. This for general case we can use this formula. For this case, for special case is this only. We can use this formula, and electric field is what? VV1, magnitude of this. Okay. Then if length of the rod I will take for this then next is what? Next case I will take next is what? Effective length concept. Effective length concept. Effective length concept. Effective length concept, I will explain this part. For example, this is a wire, a rod like this. This is a zigzag rod like this, like this. Now, zigzag rod like this. Now, this magnetic field is what inside the board given like this. Magnetic force, magnetic field is given like this. This magnetic field is what? Uniform. Uniform. Now, this rod is moving with the velocity of v in horizontal direction like this. For this case, what happen? If I will take this small section dl, this length is what? dl. If you look at this part dl, I am going to zoom it this dl part. I am going to zoom it this part. I am going to zoom it this part. If I will zoom this part, then I will get what? I am going to zoom it this part. Then I am writing here. This is the dl vector. Velocity is what? V like this. Then magnetic force. Look at this. Magnetic force direction is what? For this dl part, this velocity direction is what? I cap. And magnetic field direction is what? V naught minus k cap. Then force, magnetic force direction, Fm cap is nothing but what? V cross B, that become what? I cross minus K, that become what? J direction. Then each section, this section, I will take this part, I am given this name is what? A. This A part what? Is length, I am taking what? dl, and that length dl part will get vertical direction of magnetic force. 1 minute. Get vertical direction of magnetic force. Get vertical direction of magnetic force like this. Fm. This much dl length get the force vertical, and this is what? Moving with the velocity v. And this angle is what? Theta. If I will take this angle, theta is not required. 1 minute. Then what happen? Actually, if you force apply in vertical direction, rod incline like this. This portion incline like this, but force apply vertical direction. Force applied in vertical direction. Then what happened? No one charge coming out going to vertical direction. No one charge able to move vertical direction, because no one charge able to leave the rod. That's why leave this part of the wire. Then what happens? There is constrained motion actually. Because of constrained motion means charge able to move along the rod, along the dl length only. Then this force is vertically, this force is vertical direction, Fm force. Then positive, then this force I am going to break down into two component, and this is what? Horizontal component of force, Fmx. Fmx. I am going to break down this component. It's not horizontal. This along the rod. Fm is what? Along the rod. Along dl. Then Fm I am going to break down into other component, that is what? Perpendicular to dl. Then what happen? The positive charge means proton only able to move like this, electron able to move like this. Then this end become what? Negative and this end become positive. Means what? This DL part I am going to replace with the battery having EMF is what? Like this. This is the negative, this is the positive. This is the DE. EMF of this part is what? DE. Now DE is the EMF. How we can write DE? DE means small wire DL. The length of the DL part of this wire, EMF how much got this? V cross B, B cross B dot DL dot DL. Now this is the EMF of the small part of this. Suppose I am given this part is name is what? A. Part A. Part A of the wire means this small portion of the wire. Okay, now I will take another section also here. For example, this the part, this section I will taking about. This name given B again. Every section of the wire, B section of wire, B section of wire. If I am taking V section of wire, this looking like this only. This very almost horizontal only. Yeah, like this. Then again what happened? Vertical force will act like this, Fm. Then one component of Fm force will act like this. 1 minute. This B section of like this. Then Fm will work vertical. This is the B part. Then what happened? Then Fm one component will come like this. Fm along B section and perpendicular to like this. This is the Fm what? Perpendicular to B. Then again what happened? This end become positive, this end become negative. Then this part also I am going to replace with the battery like this. Again, this is the what? DE1. Then again DE1 what happens? Suppose I will take this part length again. It's same part this, but then again DE1 again become what? B cross B dot DL1. Yeah, you can write here E1, then DL1, then this is what? DL2, then become DL2. Okay, na? Like this. Then every section you can, if I'm break down this wire, if I'm going to break down this wire into n component, then each and every component become a battery like this, this positive, this negative. Each and every section of the wire become negative, positive, then negative, positive, then this also negative, positive, positive, like this. Then this wire means all the now all the EMF of this cell, this induced EMF is what here? In series only. Induced EMF are in series. Okay, this all in series. If like this, then we can use what? Like this. This wire, this wire I will make like this. This become what? Battery like this. This different portion. This battery again. This become like this. This become like this. This become like this. N number of cells like this, like this. Then for example DE1, DE2, DE3 and so on, DEN. Then what happen? All cells, all induced EMF is what? In series only. All induced EMF are in series. Then what happen? We can use what? We can use add only. Then we can write what? DE equal to nothing but DE1, DE2, so on, DEN. And that we can use what? Integration of this nothing but DEN. Integration of this total EMF E, we can write only this only. This is the all the battery in series we can add only. Then we can use this. Now we already know this given what? This started from A point and this end on B point. Then induced EMF become what? Total means we can use what? Integration of limit A to B. And I already know due to the small portion of wire how much induced EMF is there? V cross B dot dl. Then A to B, 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 we can write V cross B dot dl. Now, if this is the general form, E is equal to A to V, V cross V dot dl. This is a general case of the general formula for this this zigzag wire or zigzag rod placed in a magnetic field having V. If we look at this in place in magnetic field, then we can use like this. When V and B both are constant, that is not change with the time, both are constant, then we can write E is equal to nothing but V cross V will take out of integration, then we can write dl is A to B. And dl A to V, again this represent what? Displacement vector. This is what? Displacement only. This represent what? Displacement vector. Then if V and V both are constant, then we can write what? Total EMF, this only. Then for example like this is the wire like this. This is the A point A, this is what? B point. Then dl vector, this represent what? This only. You can remove this wire and replace by this and this known as what? dl A to B. This is what? Displacement vector. And that represent. then E become what? V cross V dot delta L. Delta L. Delta L. For example, like this. For example, like this. This is the one semicircular rod, a semicircular wire is placed in a uniform magnetic field. This radius of this wire, this semicircular wire radius is R, is placed in uniform magnetic field like this, and this moving the velocity of V in vertical direction. Then magnetic force direction is what? This then what happened? This is the now this is the point A, this is the point B. Then now I'm going to what happened? Now I'm going to replace this. I'm going to replace this semicircular wire with displacement vector only. If you am going to find out the induced EMF in this semicircular wire, that is this equivalent to what? This become rod like this, and this point A, this point B. This is what? Displacement vector. If I am given the velocity of V like this, then this point, this total length become what? L become what? 2R, and now become all are perpendicular this. Then the V cross V is what? J cross minus K. How much this? I, J and K. J cross K is what? I. J cross K is I. Then here J cross minus K, that become what? Minus I. Then this rod able to move like this. Then magnetic force like this. Then this end become positive and this end become negative. Then BA minus BB, that become what? BA minus BB, that become what? B 2R. Effective length is what? 2R. Here effective length is, and this displacement vector known as effective length. Effective length means you can replace this wire with the, you can replace this zigzag wire or zigzag rod by this displacement vector. Its radius given R, that become 2R, and this is the equivalent. This is the equivalent, and this is the what? Equivalent. This is the equivalent of this. This is the equivalent. Okay. Then very important formula is this. You have to remember this. We can use when VB is constant. Then directly we can use displacement vector. But when BB not constant, this not represent the displacement vector. Please remember this. When B and B are not constant, then DL is not a displacement vector here. Okay, na? This is the different behavior. Then for this case, we have to, this is the example of this. Now, the next things I will explain the next class. Will come with the more questions, and we'll practice more questions of this. This session only I will explain this part only, motional EMF. What is the mechanism? How the motional EMF? What is the mechanism behind this? I already explained what initially what happened when this start moving in a uniform magnetic field with a constant velocity. Then magnetic force will act to vertical direction. Then all proton try to drag vertical, but generally proton is what? Nucleus, that will not move, only able to get here deficiency of electrons. That's why here become what? Positive charge, a positive end here, and this become Okay, this here more electron will accumulate here because electron will move in downward direction. Then there is create the potential drop between these 2 points. If I will connect with the wire like this having resistance R, then able to definitely able to get the current also. Then conducting rod, I already explained, conducting rod containing electrons and protons, and due to the initially when it started moving, then that time only magnetic force will act. After that, electric field will develop. That will take very less time. Okay, na this steady state condition very less time. Then electric field will generate, and due to the electric field will increase when the accumulation of the charges at this and this end will increase, then what happen, electric field strength will increase. Strength of electric field will increase means there is one condition when the electric force will balance the magnetic force, because initially no electric force is nothing. After some charges accumulate here, then what happen, electric field will develop like this. Then time will increase means electric field strength will increase. There is one point when the electric force balance the magnetic force. Then the moment of charge become stop. The moment of charge become stop, then then we can use what this formula, Fm equal to Fe. Then able to get electric field is equal to this. Then electric field able to get this. It's the general formula of this. When V and V both are perpendicular, then electric field will get VB only. I already know what in the direction of electric field potential will drop like this. Then VB minus VA with negative sign, that become E dot dl. And E dot dl we can write VA minus VB. How to know VA is more than VB? I already said what you check with the direction of magnetic force. Magnetic force direction, which end side, that end become what, positive, other end become negative. Then we use this B E dot dl equal to this. Then the formula become what, VA minus VB equal to nothing but V cross B dot dl. I already said what this is the special case when the V cross B all three make perpendicular, mutually perpendicular this, then potential become what, VBL, and the electric field become VB. In general case, this case when the V is horizontal and the rod is inclined some angle theta, and magnetic velocity of this rod is what, at angle alpha is given like this, then we can use this formula, electric field and potential, electric potential. Effective length approach means suppose the wire is what, zigzag like this, then I will consider magnetic velocity of this wire is what, V, or wire or rod, zigzag rod like this. Then what happen, each section of this rod I will break down the section wise like this. Every section of the rod will take vertical force, and vertical force try to drag the charge in vertical direction. This is a magnetic force, try to drag the charge in vertical direction because of due to the constraint motion, because no one charge able to move out of rod. That's why the charges will able to move along the rod only, that is possible. Then I will break down the force into two component along the rod and perpendicular to the rod. Then this component of Fm force that will try to drag the positive charge in that direction and negative charge in that direction, and that will create the potential drop. And that will create the potential drop that much what, very small, that is I wrote here about D, and DE nothing but what, V cross B, suppose DL. If this length is DL1, then we can use like this. Then similarly I will take another section B section of this. Then again I will check the direction of the this become in positive, this become negative. The similar expression able to get here also. Then I will check each and every section, each and every part of the wire become a small battery having EMF is what, DE1, DE2, DE3, and so on like this. And then each battery is what, is like series combination. Then I am going to add all the EMF. Then for the DE1, DE2, DE3, so on. Then I will find out total EMF, that is what, integration of this. Integration means summation only. I am using this rule. Then this D, if going to integrate from A to V, then able to get the what, total EMF, induced EMF in the wire like this. Then if we assume what V cross V is constant, then we'll take the both are constant, means velocity is constant and V also constant. Then we'll take out of integration. Then integration of dl part is nothing but displacement vector, or that known as effective length. And effective length is this displacement vector, and effective length I will consider like this. And this is what the formula when E and V both are constant. And for example, I will take what one example problem like this is the semicircular rod. I am given the velocity what vertical direction V, then the force able to get what in minus I cap direction like this. And what happened, and this force try to drag each and every charge in like this. What this end able to get what positive, and this end able to get negative. And I will replace this wire with displacement vector, because here B is constant also and magnetic field also uniform and constant. Then this complete wire I am going to replace with the rod having effective. This is the initial point, this is the final point. Then I will join with this initial and final point, that become what displacement vector. And this displacement vector is become what rod like this. This is the effective length of this. Then that is moving vertical, then how much potential drop able to create, that much only, BB into 2L. The next session I will explain, next class I will explain lot of, I will come with the problems and discuss this related to this topic. Okay, thank you. Please like and subscribe my channel. And okay, that things will motivate me. And okay.